Okay, first off, let's take what we've done, and we've already, so we can review what we've already done. I told you to take the points negative 10, what was it? Negative 10 what? Negative 1, negative 8, 0, negative 4, and 2. And if we need to find out if this is linear, you need to go and build a table. So as you go here, I go to, and you build your table, and you're going to put in there the x and the y. So I've got negative 10, negative 1, negative 8, 0, negative 4, 2. Now, what does it mean to be linear? What does it mean? When I say, is the data linear, what is it saying? It makes a, okay, in there, you've got to remember this right here, that it makes a straight line. So if you looked at a graph, you would look at it and make sure that it makes a straight line. So let me kind of go back a sec here. Let's see. What if I had this? Is the data linear? No, it makes a curve. It's not linear. What about that? These are straight. But it's not a total straight line. Exactly. Very good. That's not linear. Well, maybe I'll make it not so. How about that? Yes, this is linear. That makes a straight line. Okay, so now in a graph, that's one way you're supposed to be able to tell, because remember, we've got that on our quiz, and that's one of our standards. Where did I delete? There we go. Now, I heard somebody else say, what if it's in a table? How do you know if it's linear? They have the same what? Coefficient, which is delta y over delta x. So we need to look and see here, because if you go and graph these, I know we worked on, some people are like, well, can't we just graph them and put them into the calculator when we did that stat and enter and put it in there? Yes, you could do that, but it's a little bit more difficult to see. So right here, we're going to do it with just delta y and delta x. I'm going up. This one I'm going up by 1. This one I'm going up by 2. Some people tell me that it's not linear because those numbers are not the same. It's delta y over delta x. You have to do the other side. So I have plus 2 and plus 4. Remember, delta y over delta x, 1 over 2. If you don't like the fractions, you can still divide it and get 0.5. 2 over 4. Remember, you can put 2 divide 4. Math, enter, enter, and it will reduce it to 1/2, which is the same as 0.5. Since these two, whoa, where'd it go? Since these two are the same right here, it is linear. If it is not linear, you can't go any farther. You can't not find an equation. Okay, so now I'm going to go over here and put in there 0.5. Oh, maybe I'll just do what? I'll do 1/2. You could do 0.5 if you wanted. Then times the coefficient, you put your variable, right? This is our first standard that you have to be able to do. Doesn't matter which one you do. I'm going to go through and multiply these two together. What's half of negative 8? Negative 4. So this right here is a negative 4. What do you have to add or subtract to negative 4 to get to 0? Add 4. That is your constant. Your equation, y equals 1/2 x plus 4. Okay, you have to be able to do that. Now, if you flip your paper over, we are now adding in proportionality or direct variation. So it says a direct variation or proportional relationship is a special type of linear relationship that can be written in the form y equals kx. Okay, all that means is that you write it like y equals 2x. Y equals 1/2 x. What do you notice? Or let's see, y equals negative 4x. What do you notice about all three of those equations? I do have an x. What do you mean no constant? Okay, so if there's no addition or subtraction, there's no constant that we see at the end, what number is that? 0. So in direct variation and proportion, the constant is always 0. Okay? We're going to go on with more of this in a minute, but that's a good point that if you see this, this is the examples, well, they always have a constant of 0. In a table, first you have to decide or figure out if it's linear. Underline linear. Bless you. If not, then it's not proportional. Okay? If it's not linear, it's not proportional. If you're not in Miss Crawford's class, you're not cool. Just kidding. Okay? To determine if a linear set of data is proportional, find the equation. If the equation has a constant other than 0, it is not proportional. So what it's saying is, so they give us, basically it's saying if you had y equals 2x plus 3, is the constant 0? No, this is not proportional. These up here are proportional because they have a constant of 0. So let's look down here at this table. First thing I want you to do, we have to figure out if it's linear. So right now, do delta y over delta x and figure out if it's linear. Okay, so on this first one, the first thing you need to do is find delta y, the change in y. If you don't know what this is, you can take 6 minus 1.5. You'll get 4.5. Then you have from 6 to 7.5, and that is 1.5. Oh, what is that? That is 1.5 as well. Whoops. Delta x plus 3 plus 1 plus 1. Delta y over delta x, 4.5 divided by 3. Anybody? 1.5. Then you have 1.5 over 1, which is 1.5. Okay, these are the same. So that means my data is linear, right? It makes a straight line. Now we need to figure out if it is proportional. If I take 1.5 times 1, I get 1.5. If you take 1.5 times 4, you get 6. My equation is y equals 1.5x, or y equals 1.5x plus 0. Since it has the plus 0, then guess what? It's proportional. Okay. Next one. I'm going to go down here and I'm going to do delta y. The change in y, I'm going down. Minus 4, minus 2, minus 4. Delta x plus 2 plus 1 plus 2. Delta y over delta x, negative 4 over 2 is negative 2. Negative 2 over 1, negative 2. Okay, these are the same. So that means that the data is what? Linear. Now I need to find out the equation to see if it's proportional. If I take negative 2 times 1, I get negative 2. What do you have to add to negative 2 to get to 1? Should be plus 3, right? Negative 2 times 3 is negative 6 plus 3. So my equation is y equals negative 2x plus 3. This right here, because of that plus 3, it is not proportional. Okay? Constant has to be 0. Look at these next ones. Again, if we're looking at an equation, right here, you look at an equation, see how there's nothing written there? That's the same as plus 0, even if there's nothing there. That's why it's not proportional. These over here have a minus 6 for the constant and a plus 8. That's why this is not proportional. Okay, that's a little bit easier to see. Now let's look at this. Look at these. Here's the graphs. If you have the equation, you can go and put it in your calculator and look at it. This is proportional. What is that point right there called? The origin. What is the point of the origin? Okay. Here's what I kind of give a hint. Look in proportional. See how it has 0, 0, 0, right? Because I said linear. Linear is telling you that it makes a line because it has the word line in it, right? Proportional. Gonna remind you that you're looking for 0 because it has the 0, or that it goes through the origin. Okay, that's all it's saying. Next. All right, take a minute on these two sets of ordered pairs. Make a table. Figure out if it's linear. Determine the equation and figure out if it is proportional. Do that now, please. Okay, on these, just like we did the beginning, when they give us ordered pairs like this, we need to go through and make a table. I'm going to cover that up. Let me move this down a little bit. I'm going to make my table and put my points in there. X, then Y. Not negative. 1, negative 4, 4, negative 16, 6, negative 24, 9, negative 36. So we're going to go through and do delta y. The change in y right here, we're getting more negative. Negative 12, negative 8, negative 12. Delta x, plus 3, plus 2, plus 3. If I do delta y divided by delta x, I get negative 12. Negative 12 over 3, which is negative 4. I get negative 8 over 2, which is negative 4. They are the same. They are linear. The data is linear. It will make a straight line. So then I put this in here, negative 4 times the constant. Not the constant. What am I saying? The variable. Negative 4 times 1 is negative 4. I could put a plus 0, but I don't need to. Negative 4 times 4, negative 16. My equation is y equals negative 4x. It is proportional. Didn't want to write. Okay. Let me go over here. Proportion. Where is this? All right. It is proportional. Okay? It's proportional because it's linear and it has a constant of 0. Now, go away, go away. All right. The next one, I'm going to draw a table. Put the points in there. 1, 1, 3, 7, 5, 13, 7, 19. You have to figure out if it's linear first. Delta y plus 6 plus 6 plus 6. Delta x plus 2 plus 2 plus 2. Delta y over delta x. 6 over 2 is 3. It is linear because all of these are the same. It will make a straight line. So I'm going to put 3 all the way in there, all the way down that first column. Times the variable. Well, 3 times 1 is 3. What do you have to add or subtract to 3 to get to 1? You have to subtract 2. Remember, for your first standard, you have to be able to do this table building right here and tell me the coefficient and the constant. Your equation, y equals 3x minus 2. Because there's the minus 2, it is not proportional. It's only proportional if it goes through 0, 0. Let me show you something. If I go in the calculator right here, and I go to y equals, and I put in there, say it's negative 4x, and I press graph. It looks like it goes through 0, 0, right? If all you did was see this graph. Oh, let's see. Second window, put in there 0. Second graph. Does the table say 0, 0? Yes, so it's proportional. And it's proportional because it's linear. It has to be linear first. This is what I'm saying. This is what I mean. I'm going to show you the example here. People will miss this on the test. Is this proportional? Why not? It goes through 0, 0. It has to be linear first. Write that down on the back of your paper. This is not, and sketch it, this is not proportional. It has to be linear first. Are we good? Can I go to the next part? Okay, this is the last little bit of this. I'm going to tell you right now, you guys have been doing these you've been doing proportional tables since elementary school, okay? Because even when mine come home from 3rd, 4th grade or whatever, whenever you're trying to find the pattern, it always used to go up by the same amount, right? Like you'd be adding 3, multiplying by 3, that type of thing. You guys have always seen the very nice patterns, okay? Same type of thing. The whole idea right here is when you see the term varies directly, highlight or whatever, that is the same as saying proportional. Proportional, if my pen would write. You've also been doing this for a long time in your own world. If I told you in the real world, if I told you we're going to get 25 shirts for $40, there's 25 of us, and the shirts are $400, right? Oh, yeah, we're going to get 25 shirts. The total cost is $400, and you had 25 friends. What would you do to find out how much each person has to put in? Divide. So you would go and you would take 400 divided by 25, right? How much would each person have to pay? 16. So in a direct variation, it's saying that one shirt is $16. Two shirts is $32. Three shirts, 48. What's the next one? 64. What are we doing? Okay, so tell me, how much is it for each shirt? So it's $16. Look what I'm writing down at the bottom. 16 times the number of shirts. If I wrote that as an equation, y, oh no, not y, what did it say to use? C, for total cost, the total cost equals 16 times n. Okay? N is my independent variable. N is the number of shirts. C is my total cost. And it is my dependent variable. If I asked you in this equation, what would be the domain of the situation? What would you tell me? Okay, well, it would be the number of shirts. But what numbers, what numbers are they? One, two, three, four, and I'd put up to, and I could write a reasonable number. I mean, we're not going to have like 5 billion shirts. Okay? Is this data continuous or discrete? Okay, so think about this again. Is this data continuous or discrete? Some people would, this is what I'm seeing on some of the tests, that people are trying to tell me it's continuous because it can keep on going. That's not what I said continuous was. Yes, even though your shirt only comes to your belly button, it is not half of a shirt, right? You can only buy one shirt, two shirts, three shirts. Because of that, it is discrete. It is discrete because you can only buy whole numbers of shirts. You can only buy specific numbers. If it was continuous, okay, look at me. Well, at home you can't look at me, but you can pretend. All right. People think that continuous means it goes on forever. Continuous means between 2 points, it goes through every decimal and every number. 0.1, 0.2, 0.3, my favorite, what is it? 0.9999999 of a shirt, right? You can't have that. That's why it's not continuous, okay? Discrete means it's certain numbers. Now, your shirts, if I, depend on how specific you wanted to get on your total cost, money's a little bit more difficult because you got all the pennies and stuff like that. But what type of numbers can the total cost not be? Just there's one I'm thinking in particular. One type. No, you have decimals. I mean, like in this case, you can't. Negatives. I'm talking about negatives, right? Anytime you're dealing with money, you can't have negatives. It always has to go from 0 all the way up, okay? But what if they asked you, what if the problem said, what is the domain and range? That's kind of key to you because they're asking both. Range of a function. What is that saying? Of the equation, right. And the equation is 16x. If you put that in the calculator, does the calculator know that we're talking about shirts? Does it know to not give me negatives? No. So in the calculator, it's going to give me all real numbers. Because when it talks about function or equation, it is not putting it into the real world. It's just saying what numbers could it be. Okay? I'm going to keep coming back to this because I think this is one part of that standard, one concept that we really need to hit home, and it takes a little while for you guys to remember and understand. I had many people telling me that things were continuous because it goes on forever, and that's not true. Let's just add in here real quick while we have a minute. Give me some things, and yeah, you want to put this on the back. Continuous. Give me some things that would be, if our word problem was talking about it, that could be discrete. People. Movie tickets. Any kind of tickets. Yes, positive and negative correlations will come back. Yes. Shirts. A car. Yeah. You get things that you have a certain number of. What about continuous? Time. You know, you said money. Money is a difficult one. Yes, I understand what you're saying. Technically, it would be discrete because it's certain pennies, and you can't have less than a penny, and you can't have like 0.8888 cents for something. But I understand what you're saying. So we're going to ignore money for right now. What else besides time? The height, and what are you trying to say? I'm sorry. But if you sliced a pie, you would, and if you could go with that. That's a measurement. Yes, you could go with that. If you're talking about measurement, you're also talking about like centimeters, inches. What about temperature? Right? One of the ones that blew me away, when you had water in a barrel, water in a tub, that's volume, right? If you fill up a bathtub and you let it out, that's continuous. Some people told me it was discrete because it ended. Well, yeah, it ends, but between 800 feet and 0, it goes through every decimal. Does that make sense? So even though there's a start and an end point, it still can be continuous. It's saying between the start and the end point, is it certain numbers or is it all of them? And as the bath water releases, it's every number all the way down to 0. So I would say this is volume, and maybe you want to make notes in here that it's the water in a pool, water in a bathtub, something like that to help you remember.